Let's take the Algebra 1, Unit 1 test. Question 1, which of the following is equivalent to 5 times x plus 3? 5 times x plus 3 means 5 times 3x, 15x. 5 times positive 2, positive 10. Choice 2 is the answer. Which of the following is the value of the expression x squared plus 4 over 2 when x equals negative 2? Means instead of x squared, negative 2 squared plus 4 all over means all divided by 2. Negative 2 squared, negative 2 times negative 2 is positive 4. Copy the plus 4 over 2, copy that. 4 plus 4 is 8. Copy over 2. 8 over 2 means 8 divided by 2. Choice 4 is the answer. If the expression 4x plus 1, 4x plus 3, is equal to 1, then subtract 3 from both sides. 4x equals negative 2, because 3 minus 3 is 0. 1 minus 3 is negative 2. If I divide both sides by 4, 4x over 4 is just x, equals negative 2/4, or negative 1/2, or negative 0.5. What is the value of the expression 4x plus 8? What is the expression 4x plus 8 equal to for the same value of x? 4 times the same value of x. 4x plus 8. A positive times a negative is a negative. 4 times 1 is 4. Under the 4, there's a 1. It's invisible. 1 times 2 is 2. Copy, copy. Bring down negative. 4 divided by 2 is 2. Copy the rest. And negative 2 plus 8 is 6. Choice 1. 8x plus 6 is equivalent to 8 and 6 are both even numbers. That means they're both divisible by 2. 2 times something has to be 8x, and 2 times something has to be 6. I write 4x here because 2 times 4x is 8x. And over here after the plus I write 3 because 2 times 3 is 6. This is choice 3. 2 times 4x is 8x, and 2 times positive 3 is positive 6. If Jack's age is 3 years more than twice Tina's age, T, this is saying Tina's age is T. Which of the following expressions represents the sum of their ages in terms of T? Well, I'm going to write something about Jack's age. Twice Tina's age, that's 2T, because T is Tina's age. 3 years more than what I just wrote means add 3 to this. This describes Jack's age. 3 more than, that's plus 3, twice Tina's age. This in red is twice Tina's age. Which of the following represents the sum of their ages? Sum means add. So I'm going to write Tina's age, which is blue, and I'm going to write Jack's age, which is red and green. Here's Jack's age. And if I want the sum of those, that means I have to add Tina's age, which is blue, add Jack's age. There's a 1 understood here. 1t plus 2t is 3t. Plus 3 gets brought down. 3t plus 3 is choice 4. Product means multiply. X minus 10 times x plus 2. So I start with the first term here, which is x. This x distributes. X times x is x squared. X times positive 2 is positive 2x. We can't forget about the negative 10. We distribute the negative 10. Negative 10 times x is negative 10x. Negative 10 times positive 2 is negative 20. And then we combine like terms. 2x minus 10x is negative 8x. The minus 20 just gets brought down, and the x squared up here in the beginning gets brought down. X squared minus 8x minus 20 is choice 4. Which of the following is equivalent to 2x to the 5th? To the third means I'm going to write this next to itself 3 times. 2x to the 5th times 2x to the 5th times 2x to the 5th. 2 times 2 times 2 is 8, because 2 times 2 is 4, 4 times 2 is 8. For the exponents, we add the exponents. We keep the base. X is called the base. Same base. Add the exponents. 5 plus 5 is 10. 10 plus 5 is 15. 8x to the 15th is choice 1. And then we skipped question 7. We'll go back to that right now. There's 6. Somehow 7 got missed. 7 says, which of the following equations illustrates the associative property? Associative property of addition keeps everything in the same order. If we change the order, then it's the commutative property. In choice 1, 3 plus 7 change the order to 7 plus 3. That's the commutative property. Change the order. This is not the associative property. Associative order is the same, and that the order is the same here. 5, 3, 4, same order, 5, 3, 4. But this is the associative property of multiplication. All of these numbers are multiplied. This is not the associative property of addition. And I'm going to skip choice 3 for a minute. Choice 4 is the distributive property. When you take the 2 and distribute like this, 2 times 5 is 10. 2 times positive 4 is positive 8. That's called distributing the 2. That is the distributive property, not the associative property. So 3 is the right answer, but it's a little tricky, except that it's the only one left. Number 3 is saying that if you have 4 plus 5 in parentheses plus 5, you can keep the order 4 plus 5 plus 5, but change what you have parentheses around. Order is same, 4, 5, 5, 4, 5, 5. And that's 4 plus 10, which is what this says. This is an example of the associative property, choice 3, because that really means this. Same order. We did 8 already. Number 9, we have x times x plus 4. We're going to be distributing again. And then positive 6 times x plus 4. So we have x times x, which is x squared. X times positive 4 is positive 4x. These parentheses are gone now. Positive 6 times x is positive 6x. Positive 6 times positive 4 is positive 24. And all parentheses are gone after distributing. X squared plus 4x plus 10x is 10x. I mean, 4x plus 6x is 10x. Plus 24 gets brought down. So we are looking for the expression where this says the expression that's given is equivalent to all of these except. So we're looking for the one that it's not equivalent to. The expression is equivalent to this, which is choice 3. And choice 1 and 4 are really the same thing. If you have, I'm going to rewrite the given, x times x plus 4, and then a plus 6 times x plus 4. I just wrote the given with different colors. The x plus 4 is common. It's the red thing is here and here, so I write the common thing. And next to it, I write what's left when that is removed. If I remove the red from here and here, x plus 6 is left. This given expression is the same as this. It's the same as choice 4. By the way, 6 plus x is the same as x plus 6. So we don't want that. We want the one that is not equivalent to this. And that's the same thing because x plus 6 is right there and x plus 4 is right there. If they're different orders, they're the same thing. So these are all equal to the given except choice 2. By the way, if you multiply these, which were in choice 1 and 4, you get x times x, which is x squared. X times positive 6 is positive 6x. Positive 4 times x is positive 4x. And positive 4 times positive 6 is positive 24. And here's like terms. So it's x squared plus 6x plus 4x is 10x. Copy down plus 24. And you can see that's the same as that. Number 5, we distribute again. We're going to take 5 times 3x plus 2. And then positive 2 times x minus 7. Distribute means 5 times 3x, 15x. 5 times positive 2, positive 10. That gets rid of parentheses. Positive 2 times x is positive 2x. Positive 2 times negative 7 is negative 14. No parentheses. 15x plus 2x is 17x. 10 minus 14 is negative 4. 17x minus 4 is choice 1. Product means multiply. So 3x plus 5 has 2 terms. Product means times 2x minus 3. Distribute 3x times 2x, 6x squared. 3x times negative 3, that's negative 9x. So the green is done. 3x got multiplied to everything that's there. Don't forget the 5. Positive 5 times 2x is positive 10x. Positive 5 times negative 3 is negative 15. The red 5 is done because we multiplied it to each term there. There's nothing else. The answer is 6x squared combined like terms, negative 9x and positive 10x is positive 1x. 10 minus 9 is positive 1. You don't need the 1. You could write it if you want to. Negative 15 gets brought down, and we have this answer because this is simplest form. 6x squared plus x minus 15. Number 12, if n represents a number, write an expression for 1/2 of 3 less than the number. So 3 less than the number means take the number, subtract 3. That's 3 less than the number. 1/2 of something means 1/2 times. So blue is in blue here. I think we're done. That's it. You could also write the answer as n minus 3 all over 2. That means the same thing. This time we do not simplify. We want the product of 2 binomials. So I'm going to write the given, x minus 2, and right next to that is 3x minus 8, and then a plus sign. After the plus sign, I see x minus 2 again, with 4x plus 3 next to it. So on the left side and right side of this plus sign, I see a common x minus 2. It's both, so write down what's common. Next to that, I write what is left if I remove x minus 2 from both of these. Take it out. What's left here is 3x minus 8, and then you need a plus sign. After the plus sign, take out x minus 2. This is what's left. And now we're not done because binomial means 2 terms. X minus 2 is a binomial. This is not a binomial until we combine 3x plus 4x, which is 7x, and negative 8, positive 3, that's negative 5. This is a binomial, and we have a product of 2 binomials right here. This is the answer. X minus 2 in parentheses times 7x minus 5 in parentheses. Well, the question is, why are these equivalent? Which property justifies the equivalence? What tells us that we can change this into this? 3 times 2x is 6x, and 3 times positive 5 is positive 15. We just distribute the 3 to turn this side into this side. It's the distributive property. All right, the other part of number 14, if 2x plus 5 equals 12 for some value of x, well, we're going to subtract 5 from both sides because 5 minus 5 is 0. Bring down the 2x, then nothing equals 7 because 12 minus 5 is 7. Then when we have 2x equals 7, we're going to divide both sides by 2. Because 2 divided by 2 is 1. 2x over 2 is 1x. And you can leave this 7 halves, or you can write 3.5. Whatever. What does, for some value of x, then what does 6x plus 20 equal? It would equal 6 times whatever x is, 3.5. Don't forget plus 20. 6 times 3.5 is 21. And don't forget plus 20. 21 plus 20 is 41. That's it. 41 is the answer. express x plus 4 squared as an equivalent trinomial. So I'm going to write x plus 4 times itself. X plus 4 squared means x plus 4 times x plus 4. Distribute x times x. That's x squared. X times positive 4. Positive 4x. So the red x is done because I multiplied that red x to each of these. Positive 4 times x is positive 4x. Positive 4 times positive 4 is positive 16. So I'm done with the green 4 because I multiplied the green 4 to each of these. 4x plus 4x is 8x. So the answer is x squared plus 8x plus 16. This is a trinomial because it has 3 terms. Test the equivalency using x equals 1. That means I'm going to put 1 in the original. I'm going to write 1 plus 4 in parentheses squared. And I want to see if this is really equal to this answer up here when x is 1. So I'm going to write 1 squared plus 8 times 1. And don't forget this plus 16. That's part of the answer. So I'm testing to see if these are equal. 1 plus 4 is 5, and that has to be squared. 1 squared means 1 times 1, plus 8 times 1, plus 16. 5 squared is 25. 5 squared means 5 times 5. 1 plus 8 is 9. Don't forget plus 16. 9 plus 16 is 25. So 25 equals 25. So it checks. Number 16, Anne's age is represented by the variable A. Express Jenny's age in terms of A if Jenny is 3 years less than half of Anne's age. So half of Anne's age would be half of A. Or you could write A over 2. 3 years less than what I just wrote means take 3 away. And we're done. That's Jenny's age. In terms of A means the A is in the answer. The answer could also be written, instead of 1/2 A, you could write A over 2. That's the same thing. But minus 3 still has to be there for the 3 years less than. Express Franz's age in terms of A if Franz is twice the sum of Anne's age and 7. The sum means add. We're going to add Anne's age and 7. Here's Anne's age. Here's 7. The sum of Anne's age and 7 is this blue, the sum of Anne's age and 7. Twice what I just wrote means all of that times 2. Twice is purple. Twice means 2 times. Number 17, justify each of the following manipulations to combine 2 expressions by filling in the blanks with the associative property, the commutative property, or the distributive property. So this is what we're starting with. What happened to turn this into this? 5 times 2x is 10x. I'm going to fix that. 5 times 2x is 10x, and 5 times 1 is 5. The rest just got copied. Well, that's called distributing the 5. It's the distributive property. Then we want to know how we get from here to the next step. And it looks like this turned into this by taking 2 times 3x is 6x, and 2 times positive 4 is positive 8. So this turned into this by distributing the 2. That's the distributive property. Well, this to the next line, I'm noticing everything's in the same order. 10x, 5, 6x, 8, same order. The parentheses are different places, but everything's in the same order. 10x5, 6x8, 10x5, 6x8. When the order is not switched up at all, but only what's grouped is different, that's the associative property of addition. Now I want to see how we got from this line to this line, and I see a change in order. 6x moved there and the 5 moved there. When we change the order, change order, CO, MMUTATIVE. And the two things are added, so it's the commutative property of addition. Compare this to the next line, and you'll see the same order. 10x, 6x, 5, 8. Same order, 10x, 6x, 5, 8. The order did not change, but what has parentheses around it changed. It's the associative property of addition, because the things that are here are all added, 10x and 6x, and so on. See, same order, same. Then from here to the next line is another example of the distributive property, but it's backwards. I'll show you what I mean. It's the distributive property again, because if we go from here back up to that step, we distribute the x. X times 10 is 10x, and x times 6 is 6x. And nothing different here from here over. So from here to here is the reverse of the distributive property. And there's no reason for this. I mean, all that we did was combine 10 and 6 and 5 and 8, but we don't need a reason. And we're done.